one thing that's really easy to overlook is how to handle questions that are written in a confusing way. And this question is the perfect example of that. The hardest part of the entire thing is getting around the language of the question itself. And you'll see what I mean in a second. You are given an n by n integer grid accounts, where accounts ij is the amount of money the ith customer has in the jth bank. Return the wealth that the richest customer has. A customer's wealth is the amount of money they have in all their bank accounts, and the richest customer is the customer that has the maximum wealth. And then if we look at example 1, the input is an array of arrays, and if we look at the explanation below, we can see that the first nested array represents the first customer, the second nested array represents the second customer, and then for each customer, we want to add up their values. So for customer 1, we want to add up 1 plus 2 plus 3, which equals 6. For customer 2, we add up 3 plus 2 plus 1, which is also 6. And then we return 6 because 6 is the largest sum. So I'm going to take this accounts variable right here, and I'm going to represent it on the right side in a slightly different way. And I'm doing this so that each customer has their own row. And here's where the language in the problem is starting to get in the way. So the accounts variable name right here implies that each of these rows will be an account, whatever that means. But as we just saw, each of these rows really seems to represent a customer. And then it seems like an individual account is actually one of these numbers, like 1, 2, or 3. And I say that because of the sentence right here. A customer's wealth is the amount of money they have in all their bank accounts. And that would suggest that a single amount, so one of these numbers, is the amount in one bank account. And so there's an incoherence to the terminology that's really getting in our way. So a question comes up, which is, what language should we use to describe the data? And before we jump in, let's think through our options. So we could try to continue using the terminology of the problem. The downside is that it's already really awkward and it might force us to use names that don't make sense or are unclear at best. Or we could just introduce simpler naming that makes things as easy as possible. Now in this case, I do think the existing terminology is bad enough that it's worth it to rename things. And this actually comes up a lot. There are a bunch of reasons for it, but a big one is just that clear communication is really hard, and that makes it a rare thing. Now we could try to come up with names that are specific to the financial context of the problem, since we're dealing with banks and stuff like that. But another approach would be to just rename things in a way that reflects the shape of the data. And that will make it easier to visualize what's happening as we go through our nested structure. And so looking at what we have now, I'm just going to think of each of these nested arrays as a row, and then I'll think of each of the numbers within the array very concretely as an amount, like a dollar amount. And so the mental model here is very much like an Excel spreadsheet. And then if we go back to this example, we just need to find the sum of each row. And so I'll introduce the idea of a row sum, and then we just have to keep track of the biggest sum as we go along. Now that we've defined our terms, I want to move on to implementation. So we're going to look at all of the row sums and we're going to return the maximum one. And so to start, I'll create a variable called max row sum, and I'll set it to -infinity. So I'll set it to -infinity. Now, if you wanted to, you could initialize this to 0. And the only reason you can do that is because of this last constraint, where every amount is guaranteed to be positive. Specifically, it will be from 1 to 100 inclusive. So if you wanted to, you could set it to 0. Now we want to look at all the rows. So for row in accounts, we want to compute the row sum. So I'll create a variable called current row sum, and we'll set it to 0. And then we want to add up all of the amounts in that row. So for amount in row, we'll add it to our current row sum. So current row sum, we'll just increase it by each amount. And then at the end, once we've added up all of the amounts in a row, we want to check if we have a new max for our row sum. So if our current row sum is bigger than max row sum, then we'll update our max. So max row sum will be equal to current row sum. And then our last step is just to return our result, which is max row sum, and we can submit. Our space complexity is clearly O of 1, and then for time, we have to examine every row and every element within each row, and that will take O of m times n time. Now I'm using the m and n variables as they're defined in the problem. So if you scroll down to the constraints, you can see clear definitions. M is account's length, or the number of rows, and then n is account's I length, which is the number of amounts in a given row. And then technically you have this other constraint where n is less than or equal to 50. So you could also say that the time is O of m times 50, which would simplify to just O of m. So as long as you explain your reasoning, you could also describe it this way. This problem is good practice for dealing with nested structures, but I think the most surprising thing is that the hardest part is just dealing with the language of the question itself. And that's why we asked ourselves, what language should we use to describe the data? And so when things get confusing, you can do something about it by just introducing your own terminology that makes the problem easier to work with.